more, no more, baby, I'ma do right.
Hey, what's up? I'm Adrian.
Yo, what's up? It's Keely.
And I'm Naturi, and we're
3LW,
which stands for Three Little Women. We're recording artists touring on MTV's TRL Tour. On today's NASA Connect,
you'll learn how NASA engineers are working hard to make sure that airplane pilots
and passengers remain safe in our skies. You'll visit a virtual facility designed to test ways to solve potential air and ground traffic problems at our nation's airports.
You'll observe NASA engineers and researchers using math, science, and technology to solve their everyday problems.
In your classroom, see what it takes to be an air traffic controller. It's a very stressful job. You'll also use computer technology to navigate through several phases of a flight from San Francisco to New York.
So stay tuned as Dan and Jennifer take you on another exciting episode of NASA Connect.
Hi, we're headed to San Francisco International Airport.
Great, let me check you both in and tag your bags so they arrive in San Francisco with you.
Hi, welcome to NASA Connect, the show that connects you to math, science, technology, and NASA. I'm Dan Giroux.
And I'm Jennifer Pulley. Now, before we start the show, there are a few things you and your teacher need to know. First, teachers, make sure you have the lesson guide for today's program. It can be downloaded from our NASA Connect website. In it, you'll find a great math-based, hands-on activity and a description of our instructional technology components.
Kids, you'll want to keep your eyes on Norbert because every time he appears with questions like this, have your cue cards from the lesson guide in your brain ready to answer the questions he gives you.
Oh, and teachers, if you are watching a taped version of this program, every time you see Norbert with a remote, that's your cue to pause the videotape and discuss the cue card questions.
For today's show, Jennifer and I are flying to California to learn how the people who get airplanes in and out of airports, pilots, and NASA are putting safety first.
That's right, and you know, almost 2 million people like us travel by airplane every day. Air travel links us to the rest of the world, and usually we don't pay much attention to how it works or who makes it work. But with millions of people flying, airplanes, pilots, and airports have to be safe.
Just who regulates the safety of airplanes, pilots, and airports?
The FAA, or Federal Aviation Administration. Their primary responsibility is maintaining the safety of public aviation. The FAA develops air traffic rules, operates airport towers and air traffic control centers, and encourages new aviation technology, some of which is being developed by NASA. We'll see some of those technologies later.
45, San Francisco is now boarding.
Dan, that's our flight.
And families with children are welcome to board at this time.
Mom, watch me.
You know, right now as we board, the airport's control tower has received our pilot's flight plan and will soon be directing our airplane as it taxis to the runway.
Hey, there's the control tower. Right now in that tower, people are observing us and other airplanes to make sure everything runs safely on the ground.
Meanwhile, inside the plane, we have our seatbelts fastened.
Shh, sorry. While the flight attendant gives us safety procedures.
Just like pilots and the people in airport towers have safety rules, passengers like us can make sure we are as safe as possible on the airplane. For example,
Excuse me, sir. You're gonna have to turn off that cell phone and computer.
they can interfere with the airplane's communication systems.
Well, now that we're airborne, we're being tracked on radar. Soon, our airport tower hands us off to an air traffic control center. There are 21 of these centers in the United States, and each center controls a specific area of airspace.
What is airspace?
The space where aircraft fly. These control centers communicate with pilots and safely direct all airplanes that enter their airspace. When you consider all the airplanes that fly every day, that's a huge job.
During our flight, we'll pass through about 6 different airspaces, and as we pass through each one, we're monitored by its air traffic control center.
Each center gives our pilot information about weather, air traffic around us, and it helps us navigate the best route. You know, I hope our pilot takes us over Colorado. I would love to see it from here. Hey, maybe next time NASA Connect will give us our own private jet. And then we could...
Right, Dan. Until then, flying coach, buddy. You know, no matter what route we take, our pilot and the control centers on the ground are making sure we're safe in the skies.
Would you like something to drink?
Yes, thanks. Water would be great.
Thank you.
Thank you. Speaking of safety, we learned earlier that the FAA is always searching for new technologies and ways to maintain and improve the safety of air travel. That's where NASA comes in. Jennifer and I recently visited the NASA Langley Research Center in Hampton, Virginia, to learn about NASA's aviation safety program and the math, science, and technology they use in their everyday work.
How will NASA contribute to airplane safety in the future? How do NASA engineers use math in their wind tunnel tests?
What happens to an airplane when the angle of attack becomes too great?
NASA's aviation safety program is designed to make sure that airplanes remain a safe form of transportation for all future air travelers. Many pilots and engineers like me are studying new ways to prevent accidents from occurring. We are also looking at ways to provide new ideas and technologies to airplane manufacturers and airlines so they can keep our skies safe.
Well, isn't flying already safe?
Absolutely, Dan. Flying is the safest mode of transportation, and passenger safety is the most important requirement for air travel. But you see, within the next 10 years, it is expected that close to 3 million people will be flying every day. That's about 1 million more than today. With these numbers, more airplanes will be flying in our skies, in many types of flight conditions. NASA is working to make sure that even with that increase in air traffic, airplanes will remain a safe and efficient way for people to travel.
Well, how do you do that?
One way is to make sure that all airline pilots have the necessary training to maintain control of their airplane and safely maneuver them during all flight conditions. It's my job to predict how well airplanes can be controlled in these different conditions.
How can you predict what an airplane will do?
We use a wind tunnel and model of an airplane. A wind tunnel is a facility that blows air over a model at different speeds and angles to simulate the airplane flying through the air. You see, testing full-size airplanes is too expensive, so we use scale models. This model is 1/30th the size of the real airplane.
1/30th? Hey, that's a ratio. A ratio is a fraction used to compare the size of two numbers to each other. The ratio 1/30th means that this model is about 30 times smaller than the real airplane. Right, John?
That's right, Jennifer. And we use a wind tunnel to test the model in conditions that are too dangerous to test on the real airplane. When we run the wind tunnel at different air speeds, we move the model so that the wind hits it at various angles, like this. One very important angle we look at is called the angle of attack. Let me explain. When an airplane is flying through the air, the combination of airspeed and the angle of attack produces lift, a force which holds the airplane in the air. In normal flight, as the angle of attack becomes greater, the lift increases. If you have ever held your hand out of the window of a moving car, you can feel this lift as you move your hand. However, if the angle of attack becomes too great, the air no longer flows smoothly over the wing, causing a condition known as aerodynamic stall, and the lift will decrease. Now, although this flight condition rarely occurs, the airplane's controls may not be effective, and the pilot may not be able to safely maneuver the airplane.
But John, how do you know that the real airplane is going to behave the same way that the model does in the wind tunnel?
Great question. We use math to predict how the real airplane will behave under the same conditions tested in the wind tunnel. Let me show you. During wind tunnel testing, a computer system electronically measures the lift. The computer also determines the speed of the moving air, the density of the air, and the area of the airplane's wing. Using this ratio, we can compute the lift coefficient, a number that tells engineers like me how the shape of the model, position of the model, and the airflow around the model affect lift. Next, we create a graph that allows us to see the relationship between the lift coefficient and the angle of attack we have simulated in the tunnel. Because this graph is the same for both the model and the full-size airplane, we can predict how the real airplane will fly. So let's put the data on the graph and interpret it. During normal flight conditions, the lift coefficient increases as the angle of attack increases. The pilot should have no trouble controlling the plane. However, if the angle of attack becomes so great that stall occurs, the lift coefficient decreases, and the airplane may be difficult to control. From this graph, we can determine how the airplane will respond in different flight conditions. Knowing this information allows us to find ways to help pilots prevent or avoid entering unsafe conditions and to make the airplane easier to fly.
So, once you've tested the model and determined how the real plane will behave, how do you make sure the pilots are trained in these situations?
Today's airline pilots are highly trained using very sophisticated devices known as flight simulators. The simulator looks and feels just like a real airplane from takeoff through landing, and it allows pilots to practice many different flying procedures that they may encounter during a real flight. All of the graphs created from the wind tunnel test are given to people whose job it is to input these data into the flight simulator, making pilots feel like they're flying a real airplane. The simulator is designed to respond like the real airplane that has accidentally entered unsafe flight conditions, like the ones we've tested in the wind tunnel. Using simulators, pilots are especially trained to prevent loss of control and learn how to operate the airplane under conditions that would normally not be safe in a real airplane. This training will help to ensure that air travel remains safe for everyone. In fact, many of today's students who are interested in becoming airline pilots will be trained in simulators that use the research we are conducting here at NASA. The goal of NASA's aviation safety program is to prevent accidents from occurring and for all future air travelers to know they will safely reach their destination.
Thanks, John. You know, it's really
Jen,
cool that...
check it out. It's Colorado.
It sure is, Dan. Like I was saying, it's really cool how NASA is testing models in wind tunnels and then using technology to help pilots fly safely. And speaking of technology, Dan, didn't you find a really cool CD that takes you on an airplane's journey from gate to gate?
I sure did. This CD-ROM lets you meet some of the people who operate the air traffic control system. Join me next in Dan's domain and I'll show you some of the tools they use. Welcome to my domain. Here's where I will introduce you to some cool stuff that will help you better understand the topics covered in our show. First, you need to know how to get to Dan's domain from the NASA Connect website. Just click here to enter. You'll find a link to the show's instructional technology activity. There's also a zone especially for teachers and a career zone so you can meet some of our program guests and learn about their jobs. Oh yeah, there's a page that gives links to the other neat sites that relate to the show. Now for the good stuff. It's a CD produced by NASA and the Federal Aviation Administration that will introduce you to our air traffic control system and some of the tools they use every day. It's called Gate to Gate. Speaking of air traffic control, let's visit AirVenture in Oshkosh, Wisconsin. It's the largest air show in the world, and each summer it also becomes the busiest airport in the world. Here, we'll work with the student ambassadors from the American Institute of Aeronautics and Astronautics. They are a group of high school students from around the world who are participating in an array of aerospace and education activities designed to energize and excite them about careers in aerospace. Start your journey by clicking the pre-flight airplane icon at the bottom of the radar scope. By clicking on the airplanes around the scope, you will navigate a flight from San Francisco to New York, beginning with the pre-flight and going around the scope, ending with a landing. NASA Ames Research Center, in cooperation with the FAA, is developing sophisticated software tools and procedures to help air traffic controllers manage air traffic more safely and efficiently throughout all phases of the flight. This CD will demonstrate how some of these new tools fit into the system. If you go to the Career Zone in Dan's domain, you'll meet some more of our program partners. That's it for now. But I'll be back at the end of the student activity to let you in on a new technology partnership NASA Connect has with River Deep Interactive Learning. See you then.
Hey Dan, we're getting ready to land. You know, airplanes arrive from several different directions, and the Air Traffic Control Center has to merge all those planes into a single file line, making sure there's a safe distance between each plane.
Right. And since air traffic can sometimes arrive like rush hour traffic on a highway, pilots may have to adjust their flight plans, change their speed or altitude, or go into a holding pattern. Some of these adjustments may cause delays. However, safety comes first.
That's right. When we were about 6 to 18 kilometers from the airport, the Air Traffic Control Center hands us off to the San Francisco Airport Control Tower. Tower controllers there relay current weather and air traffic information to our pilot.
Wow, what a ride. Hey, there's the control tower. I wonder what they're doing in there.
Well, let me tell you. Now that we've landed, controllers in the tower tell our pilot which taxiways to use and where we can park. You know, we're not completely safe until we've parked at the gate and our pilot has turned off the fasten seatbelt sign. San Francisco, here we come. NASA's aviation safety program is helping pilots maintain high levels of safety in our skies, NASA is also working to help airports operate more safely and efficiently. As airplane traffic increases in our skies, the possibility for more accidents or incidents also increases on the ground.
Right. Pilots have flight simulators to simulate conditions in the air. But what about people in control towers who monitor and direct takeoffs and landings?
Yeah, I mean, could all the people that guide airplanes to the ground, like pilots, air traffic controllers, and airport operators, work together and try out new ways to safely move planes around an airport?
NASA believed they could, so a unique facility was built right here in California to help solve present and future problems of our nation's airports. It's called NASA Future Flight Central.
And to learn more, we came here to NASA Ames Research Center in Moffett Field, California.
Why was NASA Future Flight Central built?
How does NASA use technology to simulate airports?
Analyzing the graph, what factors do you think influence the air traffic controller's responses?
NASA Future Flight Central is a 2-story facility with a 360-degree view. It's capable of doing a full-scale, real-time simulation of an airport. It's where air traffic controllers, pilots, and airport personnel can interact with each other and test out new technologies. As you can see, this is designed to look very much like a real air traffic control tower. The downstairs rooms support the simulation. We bring in real air traffic controllers. They wear headsets and communicate with the pilots, giving them permission to taxi, take off, and land. At the same time, they also scan the runways and taxiways to make sure that all the airplanes are maintaining a safe distance from each other, just as you do while driving an automobile.
How do you make this tower and these planes look so real?
With a supercomputer. We create a virtual airport environment, which means it is made to look very realistic when compared to an actual airport. We do this by using satellite imagery, aerial surveys, and digital photography. Simulation software allows us to move 200 vehicles, like airplanes or ground trucks, all at the same time and at realistic speeds. We can simulate a variety of weather conditions, like dense fog, rain, or snow. We can also place numerous planes on the runway that need to move all at once, making the test as realistic as possible. For example, an airplane can be placed where it shouldn't be, and the air traffic controllers have to try to safely get the plane out of the way to avoid a collision.
Nancy, that is so cool. Sounds like NASA Future Flight Central simulates many of the conditions that happen at our nation's airports.
That's right. Not only at our facility can we duplicate a real airport and operate it as it runs today, but we can also make changes and see if we can make things safer. For example, we conducted a study of San Francisco International Airport. Currently, the airport is conducting an environmental review to assess the possibility of building new runways. Because of space limitations, these new runways would be built out into San Francisco Bay. This could possibly cause the airport to relocate its control tower. Using our facility, we simulated the San Francisco airport and built the new runways. Then, for each proposed location of the tower, we moved some planes down the runway and watched the view. Without Future Flight Central, the airport might move its tower to a location with blocked views and wouldn't be able to operate the airport safely.
Has NASA used this facility to simulate any other airports?
We sure have. Recently, NASA did a study of the Los Angeles International Airport, or in airport terms, LAX. Our goal was to simulate a realistic operating environment that was as close as possible to what the LAX air traffic controllers experience every day in the tower. This study was different from the one on the San Francisco airport because before we could simulate any changes to LAX, we had to first make sure that we could realistically simulate one of the busiest airports in the world.
So, how did you determine if the simulation was as realistic as the real LAX?
Just like you do in math class, Dan. First, we collected data from the air traffic controllers using questionnaires. Using the data, we created and interpreted graphs to determine if we accomplished our goal. There were many factors involved in determining whether our simulation was realistic. Let me show you one of the graphs we created. The title of the graph is Realism Ratings for LAX Air Traffic Controllers. This graph tells us how the real LAX controllers rated our simulation.
Okay, let's see. Along the bottom are ratings from 1 to 5, with 1 being not at all realistic and 5 being identical to LAX. Nancy, what is a ground air traffic controller and a local air traffic controller?
A ground controller is responsible for airplanes on the ground, leaving the gate and taxiing to the runway, for example. A local controller issues takeoffs and landings, maintains a safe distance between arriving and departing aircraft, and is responsible for controlling flights up to 16 kilometers from the tower. Let's put the data on the graph. As you can see from the data we collected, both the ground and local controllers believe that our simulation of airplanes on the ground and in the sky met our goal of being realistic compared to LAX. In fact, the data shows that we exceeded our goal and we were very realistic compared to LAX. Just as John collects data to help train pilots for safety, Future Flight Central will realistically simulate our nation's airports so they can continue to run smoothly and safely.
Nancy, that's amazing that NASA realistically simulated one of the world's busiest airports. So what's next?
The next step will be to determine what will and what will not work when proposed changes are made to the LAX operating environment. Because Future Flight Central is a safe place to try out new airport procedures, both time and money will be saved as LAX continues to put safety first.
Thanks, Nancy. Okay, so far on today's show, Dan and I have flown from Virginia all the way to California. And during this flight, we learned how NASA's wind tunnel tests are helping train pilots to be even safer.
We also learned how airplanes and passengers get from gate to gate, and how NASA uses simulations to make airports safer.
So, do you have what it takes to be an air traffic controller? See if you can safely and efficiently land airplanes at Norbert International Airport.
NASA Connect traveled south from San Francisco to Long Beach, California for today's hands-on activity.
We're from the Boeing Summer Science Camp.
NASA Connect asked us to help you learn how to do the show's hands-on activity.
It's called In the Safety Zone.
Here are the main objectives of this game. You'll plot initial aircraft coordinates using a rectangular coordinate system. You'll use measurement tools and techniques to determine distance. You'll apply ratios to calculate the Air Safety Travel Index. You'll calculate initial aircraft distance versus actual aircraft distance traveled. And you'll work in teams to solve problems related to your own air traffic control challenges. The game board and a list of the materials you need are included in the lesson guide, which your teacher can download from the NASA Connect website. The class will be divided into groups of 4. Each group will get a flight plan to record the landing times, a tracking chart to track the progress of the assigned planes, a safety rating card to keep track of the total points earned, and the game constraint card. More about this later. Each student or air traffic controller in the group will be responsible for 3 aircraft and one of the quadrants on the game board. Your primary goal is to land each aircraft safely and on time. Now let's get started. Using the initial aircraft flight coordinates provided in the flight plan, plot the starting position for each aircraft on the game board. Use a pen along with the correct aircraft cutout to mark each starting point. Record flight number, aircraft type, and runway information on the tracking chart. Choose a colored pencil and color each designated aircraft to ensure correct tracking. Now measure and calculate the direct distance in kilometers from the assigned aircraft to the airport using the scale 2 centimeters to 5 kilometers. Record the information on the tracking chart. For each minute of play, all aircraft must make one move. One move corresponds to 2 centimeters of linear travel, 5 kilometers. Use your metric ruler to verify 2 centimeters of movement. Aircraft cannot move backwards on any consecutive move. During each minute of play, each ATC must keep track of his or her aircraft's flight paths using a colored pencil and metric ruler. After all paths have been updated, place a check mark on the tracking chart indicating completion of your aircraft's move. Check the game constraint card for landing guidelines. Study the flight plan, particularly arrival times and runway locations. The game proceeds as your teacher follows a script which indicates when to move and when conditions change. When you're finished playing the game, calculate your score using the instructions in the lesson guide. Now you're ready to determine the Air Safety Travel Index by calculating the percentage using the ratio of team points divided by total possible points. Complete the tracking chart by calculating the actual linear distance traveled from the aircraft's initial coordinates to the airport by using this equation. Calculate the difference in the direct distance traveled versus the actual distance traveled. Your teacher will conclude the game by discussing some questions with you so you can apply what you've learned during the game to the actual job of an air traffic controller.
All right, you guys need to take a look at your Air Safety Travel Index. It should be at about 100%. If it's not at 100%, there's probably a reason for this. Do you guys have any idea why it wouldn't be at 100%?
Because my plane had to fly around the mountains.
Mine was late because my runway was closed for a few minutes.
Special thanks to the AIAA chapter of Cal State University Long Beach and to Boeing Summer Science Camp for their help.
Our newest educational partnership is with Riverdeep Interactive Learning. The folks at Riverdeep are providing internet-based lessons that will enhance the math skills to go along with our NASA Connect shows. Teachers, you can find a link to this show's web-based activity in Dan's domain on the NASA Connect website. It's from Riverdeep's Destination Math series. It's a fun tutorial that guides students through information about coordinate planes. Here's a brief example.
Your mission is to explore plotting points and working with figures in a plane.
Well, we know that a plane is a flat surface that extends forever in all directions. Since this map represents part of a plane, then place...
This would be a great way to introduce the hands-on activity for this show. However you choose to use it, this web-based component of NASA Connect will give your students a useful tool for improving and strengthening their math skills. Well, that wraps up another episode of NASA Connect. We'd like to thank everyone who helped make this program possible.
That's right, and you know, Dan and I are waiting to hear from you with your comments, your questions, or suggestions. So email us at connect@lark.nasa.gov or pick up a pen and write us at NASA Connect, NASA Center for Distance Learning, NASA Langley Research Center, Mail Stop 400, Hampton, Virginia 23681.
Teachers, if you would like a videotape of this program and the accompanying lesson guide, check out the NASA Connect website. From our site, you can link to the NASA Educator Resource Center Network. These centers provide educators free access to NASA products, like NASA Connect. Or, from our site, you can link to CORE, the NASA Central Operation of Resources for Educators. That's where you can get your copy of the Gate-to-Gate CD-ROM.
So until next time, stay connected to math,
science,
technology,
and NASA.
See you then. Bye from San Francisco.
Bye.
We use math to predict how the real airplane will...
Like pilots, air traffic controllers, and airport operators. Airport operators.
Right. And since air traffic can arrive on...
Just like you're doing math class, Dan.
NASA Connect asked us to help.
Oh, this is my first position.
Why was NASA future flight? Eek.
How?
Good.
Mom.
Wake him up. Yeah, you're asleep.
I'm not asleep.
Were you rolling tape on that? That'd be a good blooper.